Welcome to this video, which will be on branching. Within programs, there are various ways that we can control and flow which parts of the code are executed. The two main ways are branching and repetition. And in today's video, we're going to talk about branching. So this is where programs might need to make some decisions about information that's available. For example, if the password is correct, then run a login procedure. There might be an image, and if you click on that image, then display something larger. You might click pay, and that would begin the execution of the code that would take money from your bank account. So all of these are examples of things where if something is true, a particular piece of code or a particular operation can take place. And the way that programs do this is through logical expressions. So what we're doing is checking logically whether something is true. And if something is true, then we can execute the code within it. So what we have here is two variables, x and y, and then if x is greater than y, do something. So the x greater than y part, that's the logical expression. That's the thing that we're evaluating. If x is greater than y, then that will be true. If x is not greater than y, then that will be false. The semicolon means that we've reached the end of the expression, so in this case we have only one thing to check, which is x greater than y. And then we have some code inside that runs if the expression is true. In this case, we're just going to print out exactly that, x is greater than y. But note that there's an indent there, so that indent is what defines the scope. So anything that you want to run, only if x is greater than y, that all needs to be indented. As soon as you push it back to be in line with that if statement, it will either cause an error if it means that there's no indented code, or you're potentially creating an error within your code where it will be run all of the time and not just within that scope of if x is greater than y. And there are quite a few different ways that we can evaluate something, that we can express this logic. So if we assume that x is 10 and y is 5, just to illustrate some of these, the one that we just looked at there was, we have like less than, greater than, we have less than or equal to, greater than or equal to. So if I want to say if x is greater than if x is less than y, what I'm actually saying is 10 less than y? No, that's false. Same if I'm saying less than or equal to, is 10 less than or equal to 5? No, false. The opposite, however, is true. If x is greater than y, so I'm assessing, is 10 greater than y? Then true, which means that whatever happens inside the scope of that subsequent code will be run. Same, is 10 greater than or equal to 5? That's true. The two at the top, however, we have equal to or not equal to. So pay attention to the fact that that comparison operator, so the thing that we're using to check, it's got two equal signs, equals equals. And equals equals means equal to. Remember that just one equals is assigning something. Like we have x is assigned a value of 10, y becomes 5. So equals equals means equal to. So the top line is if x equals y, if x is equal to y, if 10 is equal to 5, false. Not equal to assesses the opposite. So if x is not equal to y, if 10 is not equal to 5, then that is true. So whatever is inside that scope will be run. and we can combine these logical expressions together. So we can have multiple checks. So we could, using an AND, for example, if x is greater than y and x is less than 15, print out the statement is true. And we can see it appears in the console, yes, it's true. 10 greater than 5 is true. X less than 15 is true. And means that both of those things needs to be true. So true and true is overall true. This other one though, same thing, x is 10 and y is 5. If x is greater than y, true, 10 is greater than 5. And x is less than 10. That bit isn't true. 10 is not less than 10. So all that happens is Python will come to this code line here. It will check that. I will have one true element and one false element, which will mean overall the combination of and that is not true. So it will skip this next print line and then it will move on to whatever the next section of code is underneath. So it's not a syntactical error, it's not something that's wrong with the code, it's something that's wrong with the logic, that whatever is there cannot be true in this case. We have three ways of combining the logical expressions. So the first one is an AND. So we've already seen that one where we have two expressions and they both need to be true. Or is slightly different and only one of the parts needs to be true. So in this example here, I've got x equals y, x is equal to y, 10 is equal to 5. That first part is true. Sorry, that first part is false. 10 is actually not equal to 5, so that's false. This next part here, x is less than or equal to 10, that bit's true, because 10 is equal to or less than 10 is true. So that means that I have one false and one true, and because it's OR, I only need one of them to be true, so overall I'm going to report true. Not reverses the result of the evaluation. So x is equal to y is false, but by saying if not this thing, then I reverse false into true. In reality, you probably will not use not very often. You'll be using and or primarily. Now, what we've seen so far is that we can only have one choice. So we can say, if this is true, do something. But actually what often happens is you want to have alternate options. So there are various ways we can do that. The first is that we can add an else statement. So if we take this input that says select an option, and there's one option there which is to play the game. If user choice is 1, then print out, you've chosen to play the game and you can continue with the game code. Else, hey, there's an error here. So if you said just if user choice equals 1 and you had no else, the user would never know that they've done something wrong. So you can have sort of these alternate options where you know you're going to do one or the other, and else is just a mop-up for anything that isn't true in the first part. So we can see, yep, if we press 1, you've chosen to play the game, and if not, we get this error. The other thing that we can do is we might not just have one choice and then a mop-up, we might have multiple choices. So if we expand that game menu, we can see that there's two options. There's one to play the game 2 to see the high scores, and then every other key on the keyboard that I could press. So if the user selects 1, or inputs the character 1, you've chosen. Elif is how you would express else if. So if they press 1, you've chosen to play the game. Else if they press 2, you've chosen to see the high scores. Else, i.e. every other input possible, print out an error. So we can start to see that we don't have just 1 or just 2. We can have this effectively an infinite amount of choice that we can create by using else if. And then we can start to get even more complicated by nesting them. So in this case, what I've done is I've used the same example of my play game or see high scores, but I've added this variable for user plays. So currently the user plays, let's say that's the amount of times that the game has been played, is 0. So if the user enters 1, I want to print out you've chosen to play the game. Then I've got an additional if statement that can occur within that section of code. So you can see this line here. That is the scope. So everything alongside that line is going to execute if the player chooses 1. So if it's 0, I want to say, welcome to your first game. Let's say that the user plays the game. User plays becomes 1. The next time they press to play, it will say you've chosen to play the game, but this bit here won't be true, because user plays will not be equal to 0. We've just played the game and made it 1, so we would just simply skip past that part. And the other thing I've done here is I've just put the condition and the print on the same line. That's just a nice way of tidying up my code so that I'm not using up so much space vertically, effectively. Just kind of condensing a little bit neater. So we can see we've got this indent here, and then we have this nested part which is contained within that indented scope.